In this sample problem, we're asked to figure out the mass of oxygen required to completely burn 24 grams of propane gas, which is C3H8, in a barbecue. So, important keyword here is burn. This question doesn't tell us what the reaction is, what the products are, but as soon as we see burn, we know what that is. We're dealing with hydrocarbon combustion. So since it's hydrocarbon combustion, we know we have our propane. It's going to react with oxygen. It's going to produce carbon dioxide and water vapor. Like any other reaction, we have to balance this in order to ensure that we get the correct ratios. So I'm going to divvy up my products and reactants. I am not going to use that line. That's better. And I've got carbon, hydrogen, and oxygen. On the reactant side, I have 3 carbons, 8 hydrogens, 2 oxygens. Product side, I have 1 carbon, I have 2 hydrogens, and I have 2 plus 1 oxygens. That, of course, totals up to 3. Okay, I want to leave my oxygen to the end because we've got that nice and simple O2 that I can balance out as an element. Balancing out my carbons, I can multiply my products by 3. That gives me 3 carbons on each side. That also is going to increase my number of oxygens. So now I have 6 plus 1. It should be times 3, not times 6. So I now have 7 oxygens in total. Then balancing out my hydrogens, I need to multiply my hydrogens by 4 to get them both up to 8. Anything I multiply down below has to become a coefficient above. That is now going to influence my oxygens again. Now I have 6 plus 4. That gives us a total of 10. 10 and 2 is nice and easy to balance out. I have to multiply it by 5. Anything down below has to go up above. So this gives me my balanced out ratios. It is 1 propane to 5 oxygens to 3 carbon dioxides to 4 water vapors. I, of course, am going to erase all of my balancing so I can work below it. If you're working on paper, you might want to rewrite the equation now that it's balanced out so you have enough space and your paper doesn't get all messed up and unlegible or illegible. Of course, since I'm working on a tablet, this is easier for me. Next thing we need to do is write out our knowns and unknowns. We want to know what the mass of oxygen is. So we're going to write unknown grams of O2. We are told that the mass of the propane is 24 grams. Things will get a bit crowded if I try and write the formula in here, so I'm not going to do it. But it is a good practice to do it most of the time. For our molar masses, oxygen, of course, the atom has a molar mass of 16 grams per mole, which means that the molecule, which has 2 in it, always remember it's O2, not O, is 32 grams per mole. Then on the propane side, we have 3 carbons at 12 and 1/100th. And we have 8 hydrogens at 1.01. And that gives us a molar mass of 44 and 8/100th of a gram per mole. Okay. Then last thing that I need here is I need my ratio between my chemicals. I start with my propane, so that means propane is going to go on the bottom of the ratio. As usual, I'm going to put the ratio in the middle, down below. So I have 1 C3H8 to 5 O2s. You can get away with not including the 1 in front of the C3H8. If it's not there, it just implies it's 1, kind of like there's an implied 1 in grams per mole for molar mass. But I am writing it out here just to make sure it's explicit for everyone. Then where I'm going to start is I'm going to start up at my mass, and I'm going to work my way around to my other mass with that kind of semicircle shape. So writing out my equation, I am going to start. My final mass is going to be equal to 24.0 grams of C3H8. We know that's not the final answer, but the equal sign is still valid because our final mass is going to be equivalent to that many grams of propane. Next, I want to cancel out grams. I have to make sure I use the same chemical's molar mass. So I'm going to use my 44 and 800ths of a gram per mole, and I'm going to flip it upside down so that the grams cancel out with unit canceling. Then I've got my ratio, which will unit cancel out the C3H8, replace it with O2. And while I'm doing that, that corrects for the ratio between the oxygen and the propane. And finally, I'm going to use the oxygen's molar mass to convert it back to grams per mole. Plug all of that into our calculators. And that gives us a final answer of 87 and 1/10 of a gram of O2. Last thing we can do is we can check, does all of this make sense? Well, yeah, it kind of does, because the molar masses for these two chemicals aren't that different, but the propane does have a bit of a bigger molar mass. So we have a bit less than that 5-to-1 ratio that we got out of the balanced chemical equation. So we have roughly about a 4-to-1 ratio, and that kind of makes sense given what our molar masses were and the ratio between these chemicals in the reaction.